This is the EdExcel A-Level Maths Paper 3 from the 2024 series, and in this paper we will be taking a look at the statistics module. Question number 1. Zan rolls a fair die 10 times. The random variable x represents the number of times the die lands on a 6. Part A. Using a suitable distribution for x, find, for the first part of part A, the probability that x equals 3, and for the second part of part A, the probability that x is less than 3. Well, the die is fair, and we roll the die 10 times. Each roll is independent of one another. The probability of landing on a 6 is 1/6. Hence, for part A, x is binomially distributed with parameters 10 and 1/6. So, for the first part of part A, the probability that x equals 3, well, from our calculator, if we go to the distribution sub-menu, we have a binomial distribution. Press F4 so we have an x equals. We have x equaling 3 with 10 trials, and the probability is given by 1/6, and working this out, it turns out the probability that x equals 3 is 0.155, etc. Now, for the second part of part A, to find the probability that x is less than 3, we need to recognize this is the same as the probability that x is less than or equal to 2. We can change the type to a x is less than or equal to by pressing F1. In this case, x is 2. The number of trials we have is 10. The probability is still equal to 1/6. And if we work this out, you will find the probability that x is less than 3 is equal to 0.775, etc. Zan repeats this experiment each day for 60 days and records the number of days when x equals 3. Part B. Find the probability that there were at least 12 days when x equals 3. Here, we need to create a new binomial distribution. This time, we have 60 days, and we know the probability of x equaling 3, that's equal to 0.155, etc. Hence, for part B, this time, y is binomially distributed with parameters 60 and 0.155, etc. Now here, we are looking for the probability that there were at least 12 days when x equals 3. In other words, we are looking for the probability that y is greater than or equal to 12. And what this is the same as is 1 subtract the probability that y is less than or equal to 11. So we have 1 subtract. Now let's work out the probability that y is less than or equal to 11. This time x is equal to 11. The number of trials we have is 60, and the probability is 0.155, etc. So if we work this out, we end up with 1 subtract 0.788, etc. And therefore, the probability that y is greater than or equal to 12 is equal to 0.212, etc. Part C. Find an estimate for the total number of sixes that Zan will roll during these 60 days. Well, we roll the fair die 10 times, and we repeat this process 60 times because we repeat this experiment each day for 60 days. And the probability of landing on a 6 is equal to 1/6. Hence, an estimate for the total number of sixes that Zan will roll during these 60 days is given by 10 multiplied by 60 divided by 6, which is equal to 100. Part D. Use a normal approximation to estimate the probability that Zan rolls a total of more than 95 sixes during these 60 days. For Part D, we need to create a new binomial distribution. Q is binomially distributed with parameters 600 and 1/6. Where we get this 600 from is we have 10 rolls per day for 60 days. And the probability of getting a 6 is 1/6. Now, we need to approximate this as a normal distribution. And for us to do that, we require the mean and the variance. Now, in the formula book, you can see the mean for a binomial distribution is given by NP, and the variance for a binomial distribution is given by NP multiplied by 1 subtract P. So the mean is given by 600 multiplied by 1/6, which is 100, and the variance is given by 600 multiplied by a 1/6 multiplied by 1 subtract a 1/6, and working this out, we get 250/3. So therefore, Q, which is a binomial distribution, is approximately the same as R, which is normally distributed with parameters 100 and 250/3. The mean is 100, the variance is 250/3. What we are looking at in this question is to find an estimate for the probability that Zan rolls a total of more than 95 sixes during these 60 days. So, we have the probability that Q is greater than 95, and what this is approximately the same as is the probability that R is greater than 95.5. Here we've applied a continuity correction. So, from the distribution menu, if we go to the normal distribution submenu, we want x is greater than or equal to, so press F3. X in this case is 95.5. Sigma is the square root of 250 over 3, and mu is equal to 100, and working this out, it turns out we end up with 0.688, etc. Question number 2. Amar is studying the flight of a bird from its nest. He measures the bird's height above the ground, h meters, at time t seconds for 10 values of t. Amar finds the equation of the regression line for the data to be h equals 38.6 subtract 1.28 t. Part A. Interpret the gradient of this line. The gradient is given by negative 1.28. Hence, for part A, the gradient would represent the height h, which decreases by about 1.28 meters for each second of the flight. The product moment correlation coefficient between h and t is negative 0.510. Part B. Test whether or not there is evidence of a negative correlation between the height above the ground and the time during the flight. You should state your hypotheses clearly, use a 5% level of significance, state the critical value used. Here we have 10 values of t, and the PMCC between h and t is negative 0.510. Now here we are testing if there is enough evidence of a negative correlation between h and t. So, knowing that n is equal to 10, we have our null hypothesis h0 where rho equals 0, and we have our alternate hypothesis h1 where rho is less than 0. We now need to find the critical value. At the 5% level of significance with a sample size of 10, you can see that our critical value is negative 0.5494. So the critical value is equal to negative 0.5494, and we need to compare this with the negative 0.510. Well, what you can see is this negative 0.5494 is less than negative 0.510, and therefore we do not reject h0, which means we can conclude that there is insufficient evidence to suggest a negative correlation between the height above ground and time. Jane draws the following scatter diagram for Amar's data, and that's what we see here. Part C. With reference to the scatter diagram, state, giving a reason, whether or not the regression line h equals 38.6 subtract 1.28t is an appropriate model for these data. Well, we have the equation h equals 38.6 subtract 1.28t. That's a linear model. But if we take a look at the data, you can see that does not follow a linear pattern. You can see it's quadratic-like. Hence, the points appear to be suggesting a non-linear relationship, so the model is not appropriate. Jane suggests an improved model using the variable u equals t subtract k squared, where k is a constant. She obtains the equation h equals 38.1 subtract 0.78u. Part D. Choose a suitable value for k to write Jane's improved model for h in terms of t only. Now, here we have u equals t subtract k all squared. This is a quadratic equation. And if we take a look at this quadratic, if you will, effectively our maximum point is where we have this 3.5. So we need to use k equals 3.5. Now, we've got u equals t subtract k all squared, and we know that h is equal to 38.1 subtract 0.78u. And if we replace the u with t subtract k all squared, h will equal 38.1 subtract 0.78 multiplied by t subtract k squared. And using the k equaling 3.5, we can therefore conclude h equals 38.1 subtract 0.78 multiplied by t subtract 3.5 squared. Question number 3. Ming is studying the large data set for Perth in 2015. He intended to use all the data available to find summary statistics for the daily mean air temperature x degrees C. Unfortunately, Ming selected an incorrect variable on the spreadsheet. This incorrect variable gave a mean of 5.3 and a standard deviation of 12.4. Part A. Using your knowledge of the large data set, suggest which variable Ming selected. We know that there are a limited amount of variables in the large dataset for abroad locations. Here is the data for Perth 2015. Now, what he did was he wanted to find summary statistics for daily mean air temperature, but what he got was values of a mean of 5.3 and a standard deviation of 12.4. And if we take a look at rainfall and wind speed, the values he got align more with these two types of data. So he may have selected daily mean rainfall, and as I said previously, this was because there are a limited amount of variables in the large dataset for abroad locations. The correct values for the daily mean air temperature are summarized as n equals 184. The sum of the x's is equal to 2801.2, and the sum of the x squared is equal to 44,695.4. Part B. Calculate the mean and standard deviation for these data. For Part B, the mean x bar, that's equal to the sum of the x's, 2801.2, divided by n, which is 184. Working this out, it turns out we get 15.2, etc. The standard deviation is equal to the square root of the sum of the x squareds over n subtract the mean squared. So, the standard deviation is equal to the square root of 44,695.4 divided by 184 subtract 15.2 etc. squared. So we have the square root of 44695.4 divided by 184, subtract this 15.2 etc. squared, and working this out we end up with 3.33 etc. One of the months from the large data set for Perth in 2015 has a mean X bar of 19.4, a standard deviation of 2.83 for daily mean air temperature. Part C suggests giving a reason a month these data may have come from. Well, for part C, as the average temperature is quite high, it suggests we have something towards the summer. Therefore, we have October as it's the closest month to the summer period. Now here, we have to bear in mind that Perth is in the southern hemisphere. So what would be our summer would be their winter, and what would be their winter would be our summer, which is why we put down October rather than May or June, etc. Question number 4. The proportion of left-handed adults in a country is 10%. Ferreira believes that the proportion of left-handed adults under the age of 25 in this country is different from 10%. She takes a random sample of 40 adults under the age of 25 from this country to investigate her belief. Part A. Find the critical region for a suitable test to assess Freya's belief. You should state your hypothesis clearly, use a 5% level of significance, state the probability of rejection in each tale. Well, we know that the proportion of left-handed adults in a country is 10%. And what we are doing is looking at if the proportion of left-handed adults under the age of 25 in this country is different from 10%. So for part A, for our null hypothesis H0 we have P equaling 0.1, and for our alternate hypothesis H1 we have P not equaling 0.1. We have a 5% level of significance, so alpha is 0.05, and we have a random sample of 40 adults. Picking each adult is independent and the probability is consistent at 0.1, hence we can say X is binomially distributed with parameters 40 and 0.1. Now the first thing we'll do is we'll find the expected value of X. That is, in other words, the mean. The expected value of X, that's equal to 40 multiplied by 0.1, which is 4. So let's create a diagram to help illustrate what we need to do. So we've got the expected value of 4, we've got a critical point X lower and another critical point X upper, and anything to the left of X lower or anything to the right of X upper is where we would reject H0, and anything within this region is where we would not reject H0. Now, the important thing in this question is to realize we have a two-tailed test. So we have 0.025 on this side and 0.025 on this side. So let's focus on this side. We would reject H0 if the probability of X being less than X lower is less than or equal to 0.025. So what we can do first of all here is go to the tables to help us find out what X lower is. What we have here is P equaling 0.1 and we have N equaling 40. Now, where we have a value less than 0.025, well, that will be this over here, and this corresponds to x equaling 0, meaning the probability that x is less than or equal to 0 is 0.0148. Let's now focus on this side. We can reject h0 if the probability of x being greater than or equal to x upper is less than or equal to 0.025, and rewriting the left hand side, we would have 1 subtract the probability of x being less than or equal to x upper subtract 1 being less than or equal to 0.025. And this makes sense. If, say, we had the probability that x is greater than or equal to 6, that's the same as 1 subtract the probability of x being less than or equal to 5. Now, if we rearrange this equation, you will find the probability of x being less than or equal to x upper subtract 1 being greater than or equal to 0.975. And what we need to do is use the tables. So we need to find a value in this column that is greater than or equal to 0.975, and we can see that is this 0.9845, which corresponds to x equaling 8. So in other words, we have the probability that x is less than or equal to 8 equaling 0.9845. So now, if we compare x upper subtract 1 with the 8, we have x upper subtract 1 equaling 8, meaning x upper is equal to 9. Which means the probability that x is greater than or equal to 9, that's equal to, well, that's the same as 1 subtract the probability that x is less than or equal to 8. So we have 1 subtract 0.9845, which is the same as 0.0155. So therefore, for our critical regions, we have x equaling 0 or x being greater than or equal to 9. And here is that represented on a diagram. If we have a value between 0 and 9, that is where we do not reject h0. But when x is equal to 0 or x is greater than or equal to 9, that is when we reject h0. Part B. Write down the actual significance level of your test in Part A. For the actual significance, we need to add together this 0.0148 with the 0.0155. So the actual significance is equal to 0.0148 plus 0.0155, which is equal to 0.0308. In Freya's sample, 7 adults were left-handed. Part C, with reference to your answer in Part A, comment on Freya's belief. Well, the 7 is not within this region, and therefore, as 7 is not in the critical region, there is insufficient evidence to support Freya's belief. Question number 5. The records for a school athletics club show that the height, h meters, achieved by students in the high jump is normally distributed with mean 1.4 meters and standard deviation 0.15 meters. Part A. Find the proportion of these students achieving a height of more than 1.6 meters. We know that the mean is 1.4 and the standard deviation is 0.15. Hence we can say for part A, h is normally distributed with parameters 1.4 and 0.15 squared. Now what we need to do in this question is find the proportion of these students achieving a height of more than 1.6 meters. We can show this in a diagram like so. So what we are finding is the probability that h is greater than 1.6. If we go to the distribution submenu on our calculator, we have a normal distribution. The type we have is x is greater than, so we click F3. X here is 1.6. Sigma is 0.15. Mu is 1.4. And if we work this out, what you will find is the probability that h is greater than 1.6 is equal to 0.0912, etc. The records also show that the time, t seconds, to run 1,500 meters is normally distributed with mean 330 seconds and standard deviation 26 seconds. The school's head would like to use these distributions to estimate the proportion of students from the school athletics club who can jump higher than 1.6 meters and can run 1,500 meters in less than 5 minutes. Now, 5 minutes is the same as 300 seconds. The reason we convert this into seconds is because everything else is given in seconds. Part B. State a necessary assumption about h and t for the head to calculate an estimate of this proportion. Well, for part B, we would assume h and t are independent. Part C. Find the head's estimate of this proportion. Now, what we'll do is we'll create a new normal distribution of t. We know that the mean is 330 seconds and the standard deviation is 26 seconds. So we have t being normally distributed with parameters 330 and 26 squared. And what we are looking for is the probability that t is less than 300. So let's show this on a diagram. We are after the probability that t is less than 300. So on our calculator, let's click F1 because we have a less than. X is 300. Sigma is 26. Mu is 330. What you will find is the probability that t is less than 300 is equal to 0.1242, etc. Therefore, the probability that h is greater than 1.6 and t is less than 300, well, we'd have to multiply this by this. So we have 0.0912, etc. multiplied by 0.1242, etc. So we have 0.0912 multiplied by 0.1242, and it turns out we end up with 0.0113, etc. Students in the school athletics club also throw the discus. The random variable d, which is normally distributed with parameters mu and sigma squared, represent the distance in meters that a student can throw the discus. Given that the probability that d is less than 16.3 equals 0.30, and the probability that d is greater than 29.0 equals 0.10, part D, calculate the value of mu and the value of sigma. So, what we know from the question is d is normally distributed with parameters mu and sigma squared. So if we create a normal distribution, we know from the question the probability that d is less than 16.3 is equal to 0.30, and the probability that d is greater than 29.0 is equal to 0.1. So let's convert these into z values. The probability that d is less than 16.3, that's the same as the probability that z is less than 16.3 subtract mu over sigma, and this is equal to 0.3. And similarly, the probability that d is greater than 29.0, that's the same as the probability that z is greater than 29.0 subtract mu over sigma, and this is equal to 0.10. So, what we can do is find out what 16.3 subtract mu over sigma is, and we can do that using the inverse normal. So if I go to the distribution sub-menu and then go to the normal distribution, if we leave these as is and then execute, and then if we adapt this to say 0.30, you can see here we have a value of negative 0.524, etc. So 16.3 subtract mu over sigma is equal to negative 0.524, etc. And we can do the same thing here. If we change this type to x is greater than or equal to, change this to 0.10, what you will find here is 29.0 subtract mu over sigma is equal to 1.28, etc. So let's rearrange these equations. Here, if we rearrange, we end up with negative 0.524, etc. sigma plus mu equals 16.3, and if we rearrange this, we have 1.28, etc. sigma plus mu equals 29.0. And what we can do is solve these simultaneously. We have a simultaneous equation with two unknowns. We've got negative 0.524 sigma plus 1 mu equals 16.3, and then we have 1.28 sigma plus 1 mu equals 29.0. And if we solve these, what you will find is sigma equals 7.0, etc. and mu equals 19.9, etc. Question number 6. The Venn diagram, where P, Q and R are probabilities, show the events A, B, C and D and associated probabilities. We see that here. Part A. State any pair of mutually exclusive events from A, B, C and D. Well, mutually exclusive means events that cannot happen at the same time. Now, we could have A and C, those can't happen at the same time. Or we could have A and D, those can't happen at the same time. Or we could have B and D, those can't happen at the same time. So what we could put down here, for example, is A and C. The events B and C are independent. Part B, find the value of P. Well, we'd have to use this formula here. The probability of A and B equals the probability of A times the probability of B. But instead of us having A and B, we've got B and C. So, for part B, the probability of B and C is equal to the probability of B multiplied by the probability of C. Now, the probability of B and C, that's equal to 0.27. So we have 0.27 equals, then we have the probability of B. The probability of B is the 0.05, the P, and the 0.27 added together, as shown here. And we multiply this by the probability of C, and the probability of C is the 0.27, the 0.25, and the 0.08 added together, as we see here. So let's simplify as much as we can. Well, here we've got P plus, well, 0.05 plus 0.27, that's 0.32. Now, 0.27 plus 0.25 plus 0.08, that's 0.6. And if I do 0.27 divided by 0.6, I get 0.45. So P plus 0.32 is equal to 0.45, meaning P is equal to 0.13, which is added to the diagram here. Part C, find the greatest possible value of the probability of A given, not B. Before we do anything else, we can use the fact that the sum of the probabilities is equal to 1, meaning we would have to add together Q, R, this 0.05, the P, which is 0.13, the 0.27, the 0.25, and the 0.08. So, the sum of the probabilities is equal to 1, so we have Q plus R plus 0.05 plus 0.13 plus 0.27 plus 0.25 plus 0.08. That's all equal to 1. And let's simplify this. Well, simplifying, we've got 1 subtract 0.05, subtract 0.13, subtract 0.27, subtract 0.25, subtract 0.08. We can conclude Q plus R is equal to 0.22. Now, for us to find the greatest possible value of the probability of A given, not B, we'd have to use this formula here. So, the probability of A given, not B, is equal to the probability of A and not B over the probability of not B. So, everything that is A but not B, that's just this Q. And then anything that's not B, well, we have the Q, the R, the 0.25 and the 0.08, as shown here. But we know that Q plus R is 0.22. So we can rewrite this as Q over 0.22 plus 0.25 plus 0.08. Simplifying, we end up with Q over 0.55. Now, the maximum value of A and not B occurs when R is equal to 0. In other words, when R is equal to 0, because we know that Q plus R is equal to 0.22, what this statement means is Q is equal to 0.22. Hence, the probability of A given not B max is equal to Q, which is 0.22, over 0.55, which simplifies to 0.4. Given that the probability of B given not to A equals 0.5, part D, find the value of Q and the value of R. Again, we'd have to use this formula here. So, for part D, the probability of B given not to A, that's equal to the probability of B and not to A over the probability of not to A. And we know that the probability of B given not to A is 0.5. Now let's find out the probability of B and not to A. Anything that's B but doesn't include A is this 0.13 and the 0.27. So we have 0.5 equals 0.13 plus 0.27 over the probability of not A. Now, the probability of A is Q plus 0.05, so anything that doesn't include A is 1 subtract Q plus 0.05. So, we divide this by 1 subtract Q plus 0.05. So let's try to simplify this. Well, simplifying, we would have 1 subtract Q plus 0.05, which is equal to 0.5 divided by 0.4, which is 0.8. And if I solve for Q, we can see that Q is equal to 0.15. But we know Q plus R is equal to 0.22. So we've got 0.15 plus R equals 0.22, meaning R is equal to 0.07. Part E, find the probability of what doesn't include A or B and C. So, what doesn't include A or B, but does include C, well, that will be the 0.25 and the 0.08 added together. So, the probability of the set that doesn't include A or B and include C is 0.25 plus 0.08, which is 0.33. Part F. Use set notation to write an expression for the event with probability P. So what this means is we want to somehow get P by itself. So let's think about how we could do that. Well, it definitely has to include B, but it mustn't include the A and it must not also include the C. Hence, for part F, we would have B and the set that doesn't include A or C. This will give us P.